Welcome, this is Mark Anderson for Kellogg Community College, and today we're going to look at a little introduction to arithmetic sequences. And what we learned about sequences is they were an ordered list of numbers. Now, all of these sequences are going to be arithmetic sequences, which means that they have some addition pattern. They're being either added or subtracted to get from one number to the next, and the distance will always be the same from one number to the next, either by increasing or decreasing. The formula for any nth term, or to get to any specific term in an arithmetic sequence, is going to be a sub n is equal to the first term plus the number of terms we're looking for minus 1 times the d, which is the distance or difference between each of the numbers. This actually reminds me a little bit of the slope y-intercept equation, except instead of the y-intercept, we're starting with the first term instead of starting with x equals 0, or the y-axis. And to compensate for the fact that we are starting one term ahead of 0 on the x-axis, then this is an n minus 1 to compensate for that first step. But whether you care about it that deeply, please note that this a sub n is going to be the very last one we look at, or the where we stop. This is going to be the very first term, so a sub 1 is the first, and then the n, which is going to be our quantity or number there, and our d is going to be the difference between the two numbers. So for our first problem, we will actually get to use this formula because it says find the 13th term of this arithmetic sequence. So this would be the first term here, this is the second, third, fourth. And if I was asking a class that didn't actually use this formula, they would actually go 5, 6, 7, 8, 9, 10, 11, 12, and that 13th number would be the number that we're looking for. But what I want to do is I want to actually use this formula up here to find it, because on the test I may not ask for the 13th term. I may ask for the 113th term or the 1013th term. So it's important to know that we're not going to be able to list out all of these numbers. We're better off using the formula. So to find my 13th term, I'm going to plug in my first term here, and my first term here is 9. I'm going to go 13 minus 1, which would be 12, times my difference, and it looks like the difference between each of these right here is going to be a negative 6, because I'm losing 6 each time. So there's my negative 6. So by typing this into the calculator of 12 times negative 6 plus 9, or using order of operations on my graphing calculator, I get an answer of negative 63. So if I did this problem out, this would be the 13th term, that a sub 13. Now I'm going to use the formula to get to my 12th term here, so my a sub 12 is going to be negative 9, which is my first term here, plus I'm going to plug my 12 into the n minus 1, so that would be 11. And then my difference in this problem, if I look at how this is moving from one number to the next, the answer is positive 2. It is increasing by 2 each time. So this is going to be 11 times 2, which is 22, and 22 minus 9 is going to be 13. So my answer for a sub 12 is 13. And sure, I could have written out the next 9 terms here to get to the 12th term, but on the test, you're going to want to use this equation because I might ask for something bigger than 12. Now for this problem, the a sub 15, I'm going to plug in my first term, which is 7, and then add to that my 15 minus 1, which is 14, and then multiply this by my difference between these two numbers, and it looks like my difference is going to be negative 5 here. So negative 5 times 14 plus 7, my answer is negative 63. So my 15th term of this arithmetic sequence is going to be negative 63. It is a coincidence that these two numbers are the same for problems 1 and 3. But if I, wrote out my 12 next terms, the 12th term after these three, or the 15th term would be negative 63. All right, problem number 4. Find the formula for the nth term of an arithmetic sequence. Okay, so finding the formula for the nth term. This is basically saying that we're going to write a general formula, a formula where we don't actually know where this ends. But what we do know is we do know that the start of this problem is 1, and the main difference between each of these numbers as we move up is going to be 4. So I can use my general a sub n formula, so 1 plus my n minus 1 times 4. And then I'll use some distribution over here, so I'll go 1 plus 4n minus 4. And then I'll combine like terms and reorder using the commutative property, 4n minus 3. So my a sub n equation is 4n minus 3. And what's powerful about this, if I actually plug in values for n, I can get these terms. If I plug in 1, I'll get 1. If I plug in 2, I'll get 5. If I plug in 3, I will get 9. So 4 times 3 is 12 minus 3, which is 9. Problem number 5, same format, just taking my generic formula of a sub n, plugging in my first term, which is 9, and then multiplying that by n minus 1. Here in this case, we don't know what n is, so it's just n minus 1, times my difference. It looks like this is moving up each one by a total of minus 2. So that's going to be a negative. So here I have my 9 plus negative 2n plus 2, and doing some combining of like terms and reordering, so I've got negative 2n plus 11. So a sub n is equal to negative 2n plus 11. So my final problem here for this little section is I'm going to use my a sub 1, which is going to be for my general equation, my a sub 1 is going to be negative 12. Then I'm going to have 12 n minus 1 here. And this difference between here to here and then here to here is going to be a positive 2. So I've got negative 12 plus 2n minus 2, and that gives me a total of negative 14. So the 2n is in front, minus 14 right there. There's my a sub n equation. That's my generic equation. And I can do a quick check here. If I plug a 3 into this problem, I get 6 minus 14, which gives me a negative 8. Okay, so moving on to our final 3 problems here. It's going to, whoops, skip pages on me there. This is to ask about finding the number of terms in this finite arithmetic sequence. So here's what I have. I have my first term is 7, and my last term, this a sub n, is 55, but I don't know what it is. Now what I could do, I literally could just kind of go up by 3 until I hit 15, maybe count on my fingers starting with 4. But again, I might actually put a number here on the test that won't be very productive in doing that. So you're best not doing these little shortcuts. You're best using the homework time to practice really the problem itself and how you would find it. The only formula we've had so far is this a sub n is equal to a sub 1 plus n minus 1 times d, which is the distance, or the difference between the two numbers. Now in this problem, what we know is we know our a sub n, which happens to be 55, but we don't know what n is. So what's great is that if we can fill in everything else in, we can use our algebra skills to solve for n. So there's our 55, our a sub 1 is 7. Again, as I said, we don't know n minus 1, but we do know the difference here. We do know the difference between those, and the difference is going to be a positive 3. So let's continue with the algebra. 55 is equal to 7 plus 3n minus 3. So this is going to be 55 is equal to 3n plus 4. That's 7 minus 3, giving me 4. Subtract the 4 from both sides. 51 is equal to 3n. Dividing both sides by 3, 17 is equal to n, so therefore we have 17 terms in the sequence. So if I wrote out 7, 10, 13, and then went up by 3s, this would be the 17th term of this arithmetic sequence. Now this next problem here, we are going to go 1, 3, 5, so on and so forth, and we're going to get to this a sub n, so that gives me an a sub n of 15. Starting off with 1, because it's my a sub 1, we're going to use n minus 1 because we don't know the quantity of n, and our gap between each one is going to be 2. Sure, I could have counted on my fingers and go 5, 7, 9, 11, 13, 15, and figured out how many terms it would be, but shoot, where's the fun in that? Let's actually see if that is the 8th term right there. So let's go 15 is equal to 1 plus 2n minus 2. If I then subtract the 1 and the negative 2, so I got 15 is equal to 2n minus 1. Add the 1 to both sides, 15 is equal to 2n, and like I hypothesized, 16, since I added the 1 to both sides. Divide both sides by 2, 8 is equal to n, So therefore, I now have 8 terms. So that would be 1, 3, 5, 7, 9, 11, 13. Yep, that would be my 8th term. A sub 8 is 15. Now again, I could have really just done that instead of the equation, but you know, when we get to the test, you'll have very much bigger numbers. So you're gonna really need to be able to use this equation. And check this out, we're going so far into the negatives, it might be a little tricky to try to figure out where we are. So let's use the equation of a sub n is equal to a sub 1 plus n minus 1 times d for problem number 9. So my a sub n is going to be negative 66, because that is what I know there. My a sub 1, way over here, is going to be 2, plus n minus 1, we don't know that. D is our difference, so we have our difference there, which is going to be a minus 4. So there we are, minus 4 at each step. So negative 66, is equal to 2 plus, we multiply by negative 4n plus 4. So this is negative 66 is equal to 6 plus negative 4n. Subtract the 6 from both sides, we get negative 72 is equal to negative 4n. Then we divide both sides by negative 4, and n is equal to a positive 18. So this would take 18 terms to get here. So 1, 2, 3, and 15 more will get us to the negative 66. And it sure beats counting, that's for sure. And another little note is that your n will be positive in these general examples from this part of the book, because we're not going to go back in time, and we're just going to go forward from a sub 1 to see how many terms we would have. Well, thank you for watching. This is a little introduction to arithmetic sequences, and stay tuned for introduction to arithmetic series and then some story problems. Thank you.